Is this thing on?
Yeah, this sounds
All right.
sounds good. So, next essay is on dialogues on natural code. Go ahead.
Hello. Hi. That was an absolutely incredible talk. And so I'm feeling the pressure. But I'm also just like hugely honored to follow like, a talk like that. Like you could probably hear I'm shaking a bit. Like I feel the adrenaline. But let's do it. Right. So my name is Lou or Luke. It's a very long story. And unfortunately, so my co-conspirator Dave Ackley can't make it in person today, but he's going to be involved, and he's also, I think, he's in the live chat, I think, on YouTube. And I should say that this work is supported by his not-for-profit called Living Computation Foundation. Paid for my ticket today, so I just want to give thanks to anyone who's ever sort of contributed to that. If this is bad, then it's your fault. Right, so to give you some background, that's me. For a long time, I was a teacher for like most of my career. I was a teacher. I worked with really, really tiny kids, mostly, but not always with. Look, I'm shaking. I'm shaking. Oh my God. Okay, mostly, but not always with communication difficulties. But currently, I'm a software engineer at TL Draw. I'm also a researcher in residence at a lab called Ink and Switch. And I'm part of this new collective called Tentpole. But yeah, anyway, part one, Lou, that's me. So to explain this piece of work I'm showing today, I need to go eight years back to when I was a teacher, right? So that's me. That was before hormones, right? So, and when I was a teacher, I discovered these videos on YouTube by Dave Ackley. He has this whole sort of this body of work on the internet for everyone to see. And the reason I watch them is because he has a very relaxing voice. And I'm not joking. That is why I watch them. I really enjoyed how calming they were. They're kind of amazing. The setup is fantastic. It has this sort of like black background, and Dave like looks through his slides to the left, often wearing a suit and tie, not here. But after watching this video for about like 100 times, some of its ideas started to resonate with me, right? So this is Dave showing the simulation of artificial life, right? But Dave said it was more than just that. It's more than that. This is not just artificial life. This is life, right? And I thought that was interesting. That was interesting. So I started to build my own things, which were similar, and this was the first thing I ever made, sort of inspired by Dave Ackley's work, and I sort of kept going, and I haven't stopped. And so I made this thing called Sand Pond, which is like a living computation. It's a simulation, and I've kept going. This is like my latest attempt, which I presented last year at Splash at Live. And it was the first time I've presented anything like academic-y in my life. I was inspired in other ways. This is another video he did. This on the left here, that's called the self-image. It's his symbol I'll get to later. And I sort of ran with that icon, like that symbolism in some of my more artistic projects too. So yeah, I was sort of deeply inspired by Dave Ackley's work. And one day I put out this blog post on my blog. And on my blog, I usually write things that I've like learned or I'm trying to sort of reaffirm to myself. And one of the things that I did learn was sometimes you can just ask questions, right? I don't know if you know this. You can just ask for things. And I guess Dave read my blog post, so he sent me an email saying, just asking, this was immediately after the blog post, would you be interested in booking a Zoom slot sometime? Like, I've noticed you're obsessed with me, Lou. So we had a Zoom call, and it was like shortly after my birthday. And it was great, and we carried on chatting about once a month. I learned a lot from him about like working in academia for a long time, publishing lots of things, like how he thinks about code and what it means for something to be anyway. And then he said something crazy, right? He said something crazy. He said, "Let's write a paper." and I said, well, that's ridiculous. That's ridiculous. And actually, we didn't write a paper. We wrote an essay. And I'm very sorry, Jonathan, because I read your call for papers, and we wrote an essay called "Dialogues on Natural Code." Right. So one of the things that we were talking a lot about at the time was okay. So Dave has this crazy idea, right? And I say crazy as a compliment, right? And so I asked him, so why is it so important to you that we see natural language as code? Because this is something that Dave kept saying to me, right? He kept saying that all communication can be viewed as code, right? All of it. All of it. It's this crazy idea. And this idea is called, there's like a delay, natural code. Right. I'm going to work that into my timings, right? This idea is called natural code. You know, kind of like we have programming languages, right? And we also have natural languages, so we can also have natural code. It's a cutesy name, but that's what it means, right? And so we thought the best way that we could do our essay was to actually make it this dialogue between me and him, to be like this example of communication, this example of natural code. So what we did is we recorded all of our calls. We had a call a week for many, many, many months, and we recorded everything. And then in the essay, it's just snippets of that. Right, so including the bits where we interrupt each other, especially those bits. It's often the most interesting bits. But I would say that there is some cleaning up, right? It's not completely faithful. And trust me, this is what I actually said, and this is how much better it looks in the essay. So you're welcome. You don't want the truth. You can't deal with it, right? The other thing we did was, the nice thing is you can add references to something you've said. So sometimes I would say to Dave, it's oh, but trust me, I can reference that, when I've got it in the back of my mind. The other thing you can do is refer to Fig 2 in your essay. But actually, after doing this for many, many months, and we got conditionally accepted, so we actually spent a lot more time on it as well, we got quite used to this format, and many of the dialogues actually started happening async. So this particular paragraph, I wrote that top line on one day. One day later, Dave wrote the second line. A day later, I spoke on the following one. A day later, Dave wrote on the following one. So these dialogues weren't just happening at the same time. They started happening in many different ways. And yeah, anyway, back to the talk. So, to answer this question about why Dave has this idea of natural code, we figured out through this whole dialogue that it starts with this, right? It starts with this. Dave says, I think living organisms can be meaningfully viewed as machines. And that's the first line of our essay. And of course, my response is just, sorry, what? Like animals? When I think of a machine, I think of a computer or a gizmo or a gadget or a robot. But no, Dave says machines are physical arrangements of matter. They move and do work. And they have power supplies. And you know what that means, right? You know what that means, right? Does that mean we're machines? I don't feel like a machine, right? Am I a machine, right? Am I a robot? You're nodding. The thing is, I'm not this kind of machine, right? I'm this kind of machine, right? I have power supplies. I have power supplies with the food I eat and things like that. I'm an arrangement of matter. The thing is, when I go to the doctor, I kind of want them to think of me as a machine, When something's gone wrong, my immune system's all messed up, right? I need them to think about me in terms of matter and biology and bits and pieces, right? So this is the first idea, right? We are machines. Following so far? Yeah, you're just going to go with me, right? You're going to go with me on this, right? So as well as being machinery, living things are also capable of building machinery. That's what you're saying, right, Dave? That's what you're saying. You know, like we build bridges, they're machines. We build programmable machines, like Turing machines. You know, and Dave was saying that, no, it's even more than that. Like even a fire, even a campfire, we still have to build, right? Like we get bits of wood, we build this campfire, and then we like push its button, we flick a switch by lighting it to turn it on. So one example we used in the essay was burgers, right? Dave was saying to me that even a burger, even building a burger is like building a machine, right? It's a really bad example. But like, and one of the reviewers really disagreed, and I would like to thank our shepherd, Alan, for discouraging us from writing a whole page on the machine status of the burger, right? Maybe next year, right? But the thing is, if we're machines as well, like another way that life builds machinery is through reproduction, right? That's pretty, like if we really accept those first two things, you know, we are machines, we build machines, right? And I said, you know, Dave, and you're saying, just want to get this completely right, there are two ways of building machinery, right? Directly, you know, with wood, hammer, nail, we build a machine with our hands and tools. But also, indirectly, you know, you get another machine to build a machine for you, right? If you can find a programmable machine like a robot, you can ship some code to it and get it to build a machine for you. Or we can transmit code to that programmable machine. Or even just like flicking the light switch on the wall, we can kind of see it. Like if we stretch our imagination a little bit, we are like programming it in a way. It's just a very simple program. And these are some mantras that Dave kept saying to me. We ship code, right? We are coders. We could say. So catch up. We are machines. We build machines. We program machines. This is all pretty normal, and now it's going to start to go really crazy, right? Okay. So I said to him, okay, I see where this is going. So you're saying that the programmable machine could be a person, right? You could, like, if we accept those three things, then we could say that we code a person. And Dave says, yes, we transmit natural code all the time. When we talk with each other or teach stuff to our kids, you know, we could say to someone, hey, can you help me build this shelter? In a way, you're transmitting code to them. You're trying to get them to do something. You know, can you build a fire while I gather food? Or even something like, duck, there's a rock coming. You know, it's a way, you're trying to help them by coding them. We are machines, we build machines, we program machines, we are programmable. This is the crazy idea. Sometimes we're the coder. We already know we're coders. We're all coders here, right? Programmers, sorry. But sometimes we're the machine. We're the machine, right? This is the crazy idea of natural code. And Dave says, if I was trying to wrap it up all up in a box, I'd say, and we did, I think we should use, yeah, I think it's nice when you can format your speech, you know? All right, I think we should use our knowledge of programming languages, of software and computing to examine our own natural code, to understand it and debug it, to make society better and to improve our shared code base. Natural code is like another lens we can look through. It's not the only lens, it's just another lens. Warning! Warning. This is a technological fallacy, potentially, right? So reviewer C put it really well. They said, you know, they're worried about the ideological, technocratic undertones of the essay. It's a pervasive fallacy in the tech world to see all our problems as technological, right? Every human interaction, I'm saying, is reduced to a kind of programming. And I completely agree. And this was something that we were really worried about. And I think this is like a risky idea, because if people take it in the wrong way, it can be this sort of like this imposing of tech on everything, which would be terrible, right? And so I think it goes even further. I think it almost seems like psychopathic, right, to say that like we're coding people, we're trying to program and manipulate people, right? And Dave, I think he was a bit shocked by this, right? But like, I think it's really important that we see it from a different point of view. That's not what we're saying. That's not what I'm saying, right? I think we're very used to coding other people. We have a code of conduct, right? Already, we all do this already. You know, like we've all been coded by one of these things, right? You know, design systems a computer is not consuming this. It's a person that's getting coded by this. A pattern language, like it's a way of coding people, right? Advertising, you know, that's a way of manipulating people. But we should at least, why not just acknowledge that this is trying to program people to drink Coca-Cola? Actually, I had one for lunch. All right, so. Did I get programmed by my own slides? Oh, this is not subliminal. So, like, I think this is important, right? You know, like, we need to be careful. There is the potential for a technocratic fallacy, right? We can't boil down communication to just getting someone to do stuff, because that's cold, right? But just wanted to give that warning, and now we can continue with the essay, right? So, when I was a teacher, like I said, I worked with children with communication difficulties, and a lot of the time, not all the children, but some of them actually struggled to see the purpose of communication. Many of us learn this naturally, many of us don't. And so this is PEX, it's a picture exchange communication system, and it's one way of demonstrating to children and adults that communication is valuable because it can make people do things. So if you say, if you hand someone these cards, I want bubbles, and this happened many times, then I would give a child bubbles, right? And in the paper we talk about biscuits, but Dave keeps saying cookies, but either way. So you know, so many children realize that communication is valuable because when you transmit code, when you communicate, you can get people to do things. And there are ways of sort of building on this, and you can use PEX for much more complicated communications, right? But here's the thing, like, PEX is useful because it uses symbols. Right? If you don't have language, you just have to point or grab a cookie, right? But when you can use a symbol, you don't need to see the cookie biscuit to ask for it. You can ask for it in another room. You can be playing with your bubbles and ask for a biscuit. This is one of the reasons why language is great. You know, like, you can point at 3 cookies if you want 3 cookies. Or you could sort of hand over 3 cards, and then the thing is, this starts to get very cumbersome and annoying, and you know, this is when you typically, if you're a child going through PEX, then you will switch to more advanced abstract ways of communicating. Usually PEX gets very annoying, so you switch to something like a pod book, or just speech or signing, right? But I think this is like an interesting example because we're acknowledging that communication is helpful because it gets people to do things, right? We've just had to go through it explicitly here. So like a lot of this work is very inspired by my teaching days, right? Of course, it didn't take long for people to, you know, ask for, Mr. Wilson, I want 1 million cookies. No, right? Another warning. This is my favorite one, right? Non-determinism detected, right? Computers are deterministic and humans are not, right, is what I said, right, to Dave, right? How can we talk about code when it's not going to run the same way each time, right? Dave said people certainly, you know, don't do the same thing every time. Many people say, well, if it's not deterministic, then it's not computation. And I have news for you, buddy, right? Determinism is an illusion in the real world, right? All code runs in the real world. I'm sorry to break it to you. don't shoot the messenger, right? Theoretically, code runs, I don't know where, in PDFs or something, right? But all real code runs in the real world. All running code is non-deterministic. And I can prove it to you. If you think you have found a deterministic program, then bring it to me, and I can prove to you that it will not necessarily finish. All I need to prove it to you is a hammer, and I can smash your computer because it's in the real world. Anyway. The way we get around non-deterministic execution of code is that we can run it again and again and again if we think like the net gain is positive, right? We do this in web development all the time. We do retries, right? So this is how we get around non-deterministic code, is you run it again and again and again and again and again. And now we get to part 2. In that spirit, Dave is now going to tell you some of these things again.
Hey, Onward essay folks.
Could I ask for the volume to go up a bit, please?
Hey, Onward essay folks. I wish I could be there with you, but I am coming to you from last week in New Mexico. The idea here is that I'm just going to try to drill a little bit more deeply into these ideas of natural code for a couple of minutes and maybe find a few takes on them, and then hopefully, Lou will be able to make sense out of it for all of us. So, that sounds good to me as far as it goes. So the very idea, this crazy idea that saying natural language between people is like code, programming code between a programmer and a programmable machine. I think it's fair to say, as the intro, that both people and both humans, both you and I, and digital computers can be viewed not just as machines, but as programmable machines. Okay, that's great. But in almost every way beyond that, programmable machines of our kind and programmable machines of the silicon kind are almost complementary rather than identical. And one of the biggest ways that we differ is the idea of deterministic execution, that the backbone of traditional digital computing has been this idea of deterministic execution. The hardware guarantees, with an asterisk, that it'll do the same thing every time. And people don't have that kind of guarantee. Beyond just people, living systems don't have that kind of guarantee. The vagaries of the natural world means you have a plan that you're going to try to reach the apple and eat it. But as Professor Tyson once said, everybody has a plan until they get punched in the mouth. That's what non-determinism is like. And what does that mean? Well, that means if we want to think about what's supposed to happen, we have a desire, we have expressed it in code, we want to execute that code or ship that code someplace else and have it be executed there, whatever it is, we have to consider not just the plan as we have stated it, the master plan, but we have to consider the possibility that it won't work. We have to consider the possibility that it will fail. We have to consider the possibility that it will work differently on machine A and machine B. Why? Because there are implementation dependencies. And in traditional computing, in traditional programming languages, implementation dependencies are always lame. We hate implementation dependencies as programmers. We want the world, we want the digital system.
Work in web development, right? Like, and when something works different in Safari compared to Fire,
to clean all that up so that it's guaranteed to work the same way every time. That was the deal. And now you tell me it's going to do, it might be signed and it might be unsigned depending on what computer it happens to be running on. Well, I don't want to have to worry about that. Well, the real world living systems have to worry about that. And so once we get beyond determinism, and determinism is like crack. It really is a drug. It really is addictive because it allows us to skip a tremendous amount of stuff about error correcting and deciding whether we would rather have this kind of implementation problem or that kind of implementation problem. It allows us to sweep it all under the rug. That's hardware's job. Hardware provides reliability. Software provides desirability. And once we get past that, once we have to give that up, and I say we have to give it up, that's kind of why we're all here talking. Implementability becomes a primary concern. So we can take this program and we can claim, is it implementable? Can we run it on machinery that we can actually acquire? And it might be possible that the program is completely implementable in some principle, but it would cost far too many trillions of dollars to build a machine that would do it. Or it might be that it's not implementable even in principle because it has some internal contradiction where at one point it's going to say the thing has to be up and the other place it's going to have to be down. Can't be both at the same time. So that's a bummer, but we're going to have to get past that. And if we can get past that, we are going to learn that natural code has all of these techniques, all of these designs, all of this stuff. People have all of these designs and things to help make programmability possible without hardware determinism. So,
like, I love these videos, honestly. I was pleased to get like a custom-made Dave Ackley video, right? For anyway, there's more.
Once, Shannon information, send how much information can you send through a channel? Beautiful mathematical implementation, beautiful information theory, mathematics, and so forth, well understood. Has one huge assumption built into it, which is that the transmitter and the receiver share the identical dictionary. Well, that's great, and it makes sense from the point of view of the phone company. They don't care what language you speak as long as you're talking and so forth and paying the toll. But for a bigger picture, for understanding machinery in general, for understanding how to build entire systems, not just communication channels, we have to understand how does a shared dictionary come to be. And the idea is that, Chomsky's hierarchy with, recursive modular languages and subclauses and the man with the dog, with the hat, with the fun, and so forth, as a way to get complexity, well, that's great as far as it goes. But we take an alternate approach. We say we don't need incredibly complex recursive syntax if we can keep naming things. If we can say, well, A is B, or A is B and C put together, whatever it is, with very little syntax, we can start building a large dictionary and express many, many concepts. And most, I don't know. If we look at the code transmissions that are happening on Earth, if we could imagine analyzing, like the NSA, every bit that moves through every fiber and every radio wave that moves through every Wi-Fi, if we could imagine categorizing all of those computations, all of those code transmissions, a vast majority of them would turn out to be dictionary maintenance, saying A is B, A is B, B is C, and so forth. How do I know this? Because advertising is dictionary maintenance. Advertising is repeating over and over again from the valley of the
Green Giant, right?
There's tremendous.
So I think Dave was referencing, right? I had to look this up, right? Does anyone here know, like, from the valley? Right. So I'm too young.
Advertising in the world. Advertising threatens to choke the communication channels that we're trying to send other kinds of code, other dictionary entries that might be more important but less money involved than advertising. And We Are Coders is an example of a advertisement, a slogan, a symbol. Natural code, when Lou and I were having our discussions, didn't start out as natural code. It started out as, what the heck could we write a paper about? And say, well, how about natural language is kind of like programming language. It's like natural language and programming language, natural programming language, natural programming, natural code. And
right, so this is what happened, right? So me and Dave are talking all the time. And I say, that thing you said about how all language is code, right? And he would say, no, it's not quite like that, And then we have to sort of hash out this definition again of like the intricacies of what it means. And it just became so much easier. Should we just come up with a name for it? So it ended up being natural code, right?
That was a process of bumming down a program, making the program shorter, in order to make it more memorable so that we would have a nice little token that we could hang it on. That's why we settled on natural code. We Are Coders is something I came up with a few years ago before. There's a YouTube video about it. It's the same thing. I mean, when I started out, I was talking about we are programmers. I didn't like the word coders. Coders sounded, humble or not as professional, or we are programmers. But the vastly shorter length of coders completely overwhelmed. We are programmers. That is not a slogan. That is not a good punchy symbol. We are coders. it is.
Right. Next. So like there's this live programming. Do you know that there was this thing called live programming, and there was a mailing list for it a long time ago, and it was too long. It wasn't wordy enough. So they changed it to live coding, but it's been very confusing because now there's a new thing called live programming, which is, anyway, it's the same thing with natural code. It was just so much easier and quicker to say it.
So, beyond just building vocabulary, we also need to build simple constructs, simple syntactic fill-in-the-blank, role-filling sorts of things, like an API, an application program interface in traditional programming. We have this thing, you can insert at the front, you can insert at the back, you can remove from the front or the back, you can ask if it's empty, you can say, these various things. An application program interface. And we're going to do the same thing in natural code, but it's going to be obviously not built for deterministic things and so forth. And so I have tried to get myself, instead of saying APIs, which risks the confusion with traditional interpretations, I'm calling them APIs. I'm pronouncing it as a word. And we're making that be, that's a term of art. That's a jargon term for natural code. An API is a simple template for structuring code where you can fill in the blanks inside the template and get stuff that might be useful, that somebody might want to explain. And the example that we do in the paper is the idea of the self-image API. And the idea is, and again, this goes back from that video about We Are Coders, that, if we choose to say, well, among all the possible processes, the combination of an input, internal sequencing, some judgment about good and bad, and output is a set of processes that kind of all hang together that we can imagine using in lots of ways. So there's a symbol for it. You can see an input side, an output side, a sequence going around in a circle, which I can never get right, and then up and down for judgment and so forth. And they have all these places that we can use them. And so the idea is that something like this figure that we're looking at here is an API, because it suggests a way of describing many different situations. And, there's a second figure which gives a bunch of examples of all of the things that can be put into this same framework. Can it be expressed using the same API? And the claim is that is useful in and of itself, especially if we can imagine that we're doing it in a way that has a room for lots of expressiveness. And so the suggestion is there are states of people that are maybe not optimally desirable, like being depressed, where whatever it is, you're going around and around, thinking about things in your head, hating it, and that's a bummer. But maybe if we could understand it as part of a more general process of running a search process in our heads, where we try all these things and that doesn't look good enough, and so on, and they're just all failing, then maybe actually being depressed is not such a bad thing. Maybe being depressed is we're doing a good job at running our parametric search, but the search is too hard, and so forth. So my feeling is, I've gone past my time, that the idea of natural code is compelling. It's not amazing. It's not a magical theoretical framework that does anything. It's a way of speaking that has certain useful properties that we couldn't really talk about it this way until we understood programming and digital computing and programming language design to the level that we kind of understand it now. To me, it seems like the early days of design patterns, that there is low-hanging fruit all over the place here, where we could start fleshing out natural code APIs, natural code APIs, and exchange them with each other and say, this is compatible with that, these things go together. We could build a natural code framework that will have more and more and more scope. And that could be good for our computation as a society altogether. Lou, save me.
Okay. I'm already over time. So I'm going to race through and maybe cut some stuff. But so yeah, this is the self-image that I showed you earlier. This is like just a way of thinking about a computation, whether that's like an unnatural computation, like a computer program or a natural computation like a computer program, right? And Dave gets it. I used it too, but we were kind of both doing this on our own. You know, we were both doing it on our own and just using it for like introspection or something, and that's not very helpful, right? So the whole idea of this, our dialogues, was that we wanted to like sync up, right? Are we talking about the same thing? What are we talking about? And throughout this whole process, I think me and Dave ended up finding some shared language around it, and that's like kind of the output of this work is this word natural code. We know what we're talking about now. There are some things I'm going to skip over now. Come speak to me afterwards. Speak to me afterwards. Do you know what? Actually, I think it makes it better if I just go through the slides like this. We don't need any syntax, right?
Is that syntax?
That's next year, right? Do you know, this is a way better way of doing a presentation. What I will end on, this is because this is the important stuff. The other stuff was just bonus. Is that, yeah, like I said, this process of these dialogues between me and Dave, it was about building APIs, or to be more specific, building one API between me and Dave, right? For me, it's building bridges, and that's what this natural code idea is about to me. It's about knowing that we're maybe sometimes speaking different languages, and we want to know how to translate between those, right? It's a very general, like high-level idea. I don't think we cut vagueness as a service from the essay. It was in one of the versions. It's been this crazy, exciting experience. Me and Dave, like I'm essentially the second natural coder. Next, I think I'm interested in sharing this more widely and seeing how people react. I have no idea how they're going to react to this crazy idea. We're going to go step by step. That's the end. Thank you very much.
Thank you very much for the talk. There's time for questions. Please line up.
So tall. Excellent
Maybe try
talk.
to make it brief, though. The line is long.
Oh yeah, sorry, I didn't leave much time. But
That's fine. Go ahead.
I'm just gonna do this so I don't have to like crane my neck. Excellent talk. Super funny and really like just incredible ideas I was not expecting. Embrace death?
Right, do you want to ask about Embrace Death?
Of course.
Right, okay, so Embrace Death is, I'm going to go all the way back, is this mantra that I've been using in another project called the Taddy Web, which I gave a talk about a few weeks ago. Go look on toadpond.com and look for Death of the Taddy Web. But it really takes on board robust first principles. And robust first computing is when you really lean into the non-deterministic execution of code, right? Where we expect code executions to fail, right? So it's like, you can say, yeah, embrace death of code, embrace failure of code. I think one way of coding is to try to avoid mistakes. Another way of coding is to try to embrace mistakes and just be ready for them. So that's embrace death. It's not as dark as it sounds.
Very cool. Thank you.
So I wanted to ask, because what you are describing seems really to me like some semiosis, which is the process of transferring meaning of the thing we are talking about. That is pretty prevalent in like human studies or like social studies. Mm-hmm. Is it something that you consider? Like we already have some framework of describing a meaning. I think this one is nice as well, but have you considered them together sometime?
Yes, and there's more. You should read the essay. There's a bit more on that. I think one of the things that I think is important is this is just yet another lens for looking at things, right? It's not made to replace anything. I think It's been interesting to see what kind of contexts this can be helpful or actually not helpful. But I think, so I don't want to take up too much time, but yes, I think it's not supposed to be the one true way of seeing things. It's just, hey, here's another way. If the others don't work, you got another one to try now. Yeah.
Hi, this was a really interesting talk. I was wondering, like, when I think of code, I think of it as a tool, and so like it's in service of some sort of like engineering goal, like there's a goal.
Yeah.
So I'm wondering if this lens produces like an ethical obligation to engineer language to fit some sort of goal. Like, I
Right.
guess I'm thinking if you've heard of like conceptual engineering in philosophy.
I
like
have
that-
not.
Okay.
I'm so pleased you mentioned this. I'd love to learn more about that. Yeah, but that's really interesting saying like code is a tool. And I think that's how I think about like communication. You know, like when I communicate, it's one of the many tools I have to, I guess, like interact with the world, right? But I'm afraid I don't know anything else than that. But I'd love to speak afterwards.
Okay,
That
thank
sounds
you.
really cool. Yeah.
So I think this is kind of echoing from some of the previous questions, and I'd love to just talk to you more after. This gives me ideas for kind of a few papers, because there's things in here that feel like echoes of like kind of like Foucauldian perspectives on discourse, maybe like some Hegelian perspectives on contradiction. And I guess my question is like, if you go back to like some of these big philosophers who talk about, you know, discourse and language and all of these things, are there particular ones that you're most interested in bringing this work into conversation with in the future? Or is it just kind of like sky's the limit, you know, go where the night takes us sort of situation, embrace the death of it all?
Right. Great question. The sky's the limit.
Perfect.
So one thing I would say, boom, step by step, right? It's this little like mantra and slogan where I think we're trying to figure out what this is bottom up. It's not that we have like a top-down perspective with certain goals. I think this is part of I guess this robust first style of meaning building, right? Is to like build up our primitives, and one of them is natural code. Yeah.
Right. Thank you.
Thank you.
Loved your talk, by the way.
Thank you.
So I just started reading on the plane on the way down here. Irving Goffman's book, The Presentation of Self in Everyday Life.
Right.
Okay. He wrote this in 1959, but it's all about, whenever we communicate,
Yeah.
we are performing. There are observers and actors in this, and there's all this stuff that goes on, subtle negotiation about how we communicate.
Right.
And I think that makes APIs much more complicated in real life than in code that is unnatural code. So it would be very interesting if you read that book and thought about it, if there's some other interesting patterns to come up. But anyway, that was just my thought. Yeah.
Thank you. Can you show me
Yeah.
that later?
Yeah.
That sounds great. I think one of the reasons, right, this whole idea has been interesting to me is because it's about, a lot of it is about we can have a look at how we define ourselves, right? Like how we like you say, like perform in a way, right? And yeah. So yeah, that sounds really interesting. Yeah.
So this is, again, a variation on questions people have asked, but you know, there's lots of literature in psychology from the pre-computer days that has
Yeah.
considered how we can understand and systematize and find patterns in our thought processes and in our interactions with each other. But I think part of the thesis, if I understand it, of natural code is that by viewing things from a computational lens, this is generative in a way. It brings us to new insights we might not have had exploring things the same way, but just with a set of concepts that existed like pre-1950. And you know, I suppose API is one of them, but it's still a little bit unclear to me, like, what are kinds of ideas you hope to get through this line of inquiry, where it's really like you need this metaphor to, or like this metaphor productively generates those ideas in a way that would be difficult without it?
Right. Really great question. One of the challenges I put to Dave in the essay was, isn't this just a psychology model? And I did a psychology degree, so check out his answer. I would say that one of the big things is it it's more of a blueprint. This kind of model is more of a blueprint for how to implement programmable machines. It's not just trying to observe like how a person is or works. It's about, right, this is how we could implement something. And I could go more into like what that really means. Yeah, I should probably end there.
Okay, thanks.
Maybe some last comment. For, well, quite some time now, I've been wondering, coming from a Smalltalk background, what makes a good Smalltalk programmer, what makes a bad Smalltalk programmer, how to teach these practices quickly. Also coming about exploratory programming, what does it mean? How do you think about your problems? And when I saw this, well, jump to social coding and how to, well, better interact on a social level, it reminds me of teaching, and then maybe there's a way back to program these other machines, like, yeah, these ones.
Right.
And maybe you have a quick final comment on that. If there's a way back, if you have a better social coding, like this model you showed at the end, is there a way back to this more technical things we're doing right now?
So, I mean, for me, the clearest way back is through this non-determinism, right? Because I think we assume that we assume that things are going to run the way that we expect all of the time, and partly because we can't always rely on that in the real world when we're trying to make things for the real world. And so far, I think that we should make things for the real world, so we should be interested. But sometimes we just make mistakes, and so like, you know, we code things in a way where we should expect some mistakes, and so, you know, we should embrace the non-determinism of that. And I think there are some huge blind spots. There are some huge blind spots in like computer science because of this sort of addiction to determinism. And the thing I presented last year, the reason it worked was because it was fully non-deterministic, and so it hadn't been done before. So I think there's lots of low-hanging fruit for non-deterministic computation. So I'd say that.
Thanks again for the talk. This brings us to the coffee break. So be back in 30 minutes, I say.